In this paper, we begin by selecting a robust BERT baseline. We utilize the exact architecture of BERT base and BERT large as our baseline models. BERT base comprises 12 repeated transformer blocks, a hidden size of 768, an intermediate size of 3072, 12 attention heads, and 12 hidden layers. On the other hand, BERT large includes 24 repeated transformer blocks, a hidden size of 1024, an intermediate size of 4096, 16 attention heads, and 24 hidden layers. We then proceed to modify the architecture of MosaicBERT for faster pre-training. We adjust the flash attention layer to decrease the number of read-write operations between memory. We also introduce attention with linear biases, alibi, to encode position information directly through the attention operation. Additionally, we employ gated linear units, GLU, for the feed-forward sublayer of the transformer. In the third step, we make modifications to the feed-forward layers. We utilize the GLU activation function in conjunction with GLU. We also make additional modifications, such as altering layer norm modules to run in B-float 16 precision instead of float 32. We concatenate all examples from a mini-batch into a single sequence of batch size 1 to prevent wasted operations on padding tokens. We apply a 30% masking ratio for the masked language modeling, MLM, pre-training objective and apply dropout to the feed-forward layers but not to the flash attention module. For pre-training optimizations, we use the Colossal Cleaned Common Crawl, C4, corpus. We convert the C4 dataset to the streaming dataset format for efficiency and use B-float 16 mixed precision training. We also increase the vocab size to be a multiple of 64. Finally, we present our results. MosaicBERT base achieves a downstream average GLU, DEV, score of 79.6 in 1.13 hours, demonstrating a significant speedup compared to BERT base. MosaicBERT large achieves an average GLU score of 83.2 in 15.85 hours, also showing a considerable speedup compared to BERT large.